Hi, so today I will be discussing about the different methods of riser designing. So we were continuing riser designing. So in this there are four methods. One is modulus method, Caine's method, naval research laboratory method, and fourth one is volume shrinkage method. So we have already discussed about the modulus method, where it is given that modulus of riser should be greater than modulus of casting. This is obvious, but it is given that how much greater it should be. So modulus of riser should be 1.2 times of modulus of casting. Okay, so this has been discussed in the last class. Next we will go for Caine's method. So Caine's method, it talks about one equation. This equation is x is equal to a upon y minus b plus c. Just we have to remember this one, where what is x and y so is freezing ratio. Okay, and y is volume ratio, or volumetric ratio. Now freezing ratio is given by modulus of riser divided by modulus of casting. If we can remember this one, actually this is not the definition, rather definition of freezing ratio is ratio of cooling characteristic of casting to the riser. Okay, so ratio of cooling characteristic, that is the freezing ratio. But to remember, or like in the examination, don't be confused, just remember modulus of riser divided by modulus of casting, because modulus of riser is inversely proportional to cooling characteristic of riser. Clear? So here we know V by A of riser divided by V by A of casting. Volumetric ratio, V of riser divided by V of casting. Okay, so riser will always be on the top in the numerator. Okay, so in x and in y, riser will be in the numerator. So remember this, always you should be using riser at the top and casting at the bottom. Clear? And we know that modulus of riser is greater than modulus of casting. That means x will be always greater than 1. X will be always greater than 1. As soon as you remember x is always greater than 1, so obviously the modulus of riser should be in the numerator, modulus of casting will be in the denominator. So in this way you have to you have to memorize these things. So x is always greater than 1, then only riser will solidify at the last. So freezing ratio should be greater than 1. So understood? So actually it is not this definition. So freezing ratio definition, if it is, then you will be writing this one. Okay, never write this modulus of riser divided by modulus of casting. It's a ratio of cooling characteristic of casting. Clear? And A and B and C are constants which are different for different other materials. Okay, so let's move. So if we plot x and y on different axes, then how it will look like? So y on the y axis and x on the x axis, then we will get a curve like this one. Okay, parabolic. So this gives us boundary. Okay, so above this we will get a sound casting. That means riser will solidify after casting. Okay, and but in this region riser will solidify before casting. So then we will get defective casting, isn't it? So that is how we use the Caine's method. So we have to remember this formula: x is equal to a divided by y minus b plus c, where x is equal to freezing ratio, y is equal to volumetric ratio, x is equal to modulus of riser divided by modulus of casting, y is equal to volume of riser divided by volume of casting. So next we will move. So here there are different metals. Okay, and it's A and B and C are given. So there is no need of remembering. This will be provided in the question. There is a one question given here, which is asked in IES 2007. So here it is given that size of we need to calculate the size of a cylindrical riser. Okay, so the riser which we have to calculate, it is having height and diameter equal. H is equal to D, necessary to feed a steel slab casting of dimension this much. Okay, with a side riser. It is given side riser, casting poured horizontally into the mold. So we will calculate the dimension of riser using Caine's method. Okay, I think this same question is also given here. Oh, okay, it's not that one. Here this value is changed. Anyway, so just we have A, B and C given. So put it there. First of all, we will calculate x and y. Okay, so from there we can easily calculate. Okay, so here let me delete that all. Okay, so in this question, volume of riser, volume of casting is given, that is or dimensions of casting 25, 25 and 5 centimeter cube. Okay, so we have the formula x is equal to a divided by minus b plus c. A, B and C are given. X is equal to modulus of riser divided by modulus of casting. So can we calculate the modulus of casting? From here, okay, so modulus of casting is equal to volume of casting divided by area of casting. Is it not? Or area of casting divided by volume of casting. Which one will be true? So this one is true, isn't it? Because modulus will be higher if area is lower. Okay, so put it here. We get 25 into 5 divided by area is 25 into 5 into 2 plus 25 into 25. So we get here, just use the calculator. This is 25 25 by 7, or okay, 25 by 7. We got this. We need to find out the modulus of riser. Okay, it's a side riser, so and cylindrical side riser. For cylindrical riser, with d is equal to h. So what will be modulus of riser? So modulus of riser will be d by 6. We know that. So from here we got that. So we will put it here and we calculate x. So x will be 25. D by 6 divided by 25 by 7. So it will give you 7d divided by 150. X we have got in terms of d, unknown. Okay, similarly by we will get in terms of unknown, so in terms of d. So volume of riser will be how much? Pi d square by 4 into h. H is equal to d, so by pi dq by 4. So by so by can be written as volume of riser, that is pi dq divided by 4 divided by volume of casting, that is 25, 25 and 5. How much is that? Pi dq divided by 12500. Clear? So we got this x and y. Put it here in this equation and solve this equation, because it is a dq. So obviously it is a this dq, and this will be d. So it will be d to the power 4. So we will get a equation, an algebraic equation with exponent 4. So after solving, we will get 4 degree equation, 4 solutions of x and y. Okay, among them the best suited will be used. Okay, so this becomes a little bit complicated, because the equation which is coming here, just see here how the equation will be there. Let me delete from here. Okay. So just put it x, that is 7d by 50 is equal to a. Leave it because it's a constant. Pi dq divided by 12500 minus b plus c. C is a constant, so just put it here this side, so minus c, okay, into the, so we got 7d by 150 minus c into pi dq by 12500 minus b is equal to a. Now just multiply this one and we are getting a equation in terms of d to the power 4. Okay, so something we will be getting is equal to something 0. Now solving this d to the power 4, you will be getting 4 equations. D value, there will be 1 2 3 4 values, isn't it? Out of this the most suitable one we will choose. Okay, so this becomes a little bit lengthier, so we will not go for that. The solution, sorry. Now we will move further and we will go for Naval Research Laboratory method. So I'll delete everything. Okay, Naval Research Laboratory method. So actually Caine's method is becoming very troublesome. So what we are going to do, we are going to simplify it, and this was simplified in this one, Naval Research Laboratory method. So here what we are doing, freezing ratio is replaced by shape factor. So what we need to define shape factor. So shape factor for any shape is equal to length plus width divided by thickness, or just L plus W divided by T. So now how are you going to find out length, width and thickness? So actually it is the maximum dimension of the casting section. Let's suppose there is something like this kind of casting is there. So it's a 3D casting, isn't it? So what we are going to do, we are going to find the maximum length. So this is length, maximum dimension, this is width, and there is something thickness somewhere. Okay, so this is the thickness. Okay, so in this way we are finding the shape factor of any shape. Okay, so after as we can see here, length plus width by T. Okay, so it depends. There is a like by different experiments it has been, this curve has been drawn, and it is having a region. Okay, so in between this region, actually if that is coming, then we will say that riser will solidify after the casting. So from the shape factor we can calculate the riser volume divided by casting volume. Are you getting? So from that, one second. Okay. Okay, so here from the shape factor we got the shape factor, and from here we can calculate what? Volume of riser divided by volume of casting. That is volumetric ratio. Okay, so volumetric ratio, that isn't it? So this by can be calculated from shape factor. So as let's suppose the shape factor comes 14, so just corresponding to this, check that what is the riser volume. Are you getting? So in this way we are getting the values of, so from here we have volume of casting given, so from here we can calculate the volume of riser using Naval Research Laboratory method. So this is the procedure. First we have to do what is, we have to calculate shape factor. Okay, and from there we have to from the graph which is given here we will get riser volume to casting volume. Okay, so in the question either a graph will be provided or a table will be provided. Okay, then after from there we will calculate volume of the riser, and if there is any relation between H and D, then we can calculate easily the diameter of the riser. Okay, now some of the points, like for circular plates the length and width are same as that of the diameter. Okay, so if there is a circular plate, so the length and width is same, so that is D plus D upon T. Thickness, maybe it will have some thickness given. Okay, for cylinder the width and thickness are same as diameter for calculating the shape factor. In case of cylinder, width and thickness are same as diameter for calculating the shape factor. So in case of cylinder, okay, this is length and this one is width and the thickness is this one. Okay, so W and T in case of cylinder, very important, shape factor for cylinder is equal to length will be length of the cylinder, width D divided by T. This is plate, circular plate. So S of circle, just write circle, is equal to d plus d by t. But for calculating the riser volume, actual casting volume is to be used. So we have to use actual volume. So there is a question. Let us solve this one. The other shape of interest is hollow cylindrical shape. We have to know. In this, the heat removal is restricted. A correction factor K needs to be applied to get the effective plate thickness. Okay, so if T is the true wall thickness, then from there we will multiply with K. So correction factor is given here. If the core diameter is 0.5 of the thickness, then correction factor will be 1.17. Okay, here why this correction factor? Because of the restriction of heat removal. In case of hollow casting, what happens, that the heat is trapped inside. So due to this, you can say that we need this thickness will be multiplied with certain value, and all the values are greater than 1. All the values are greater than 1, correction factor. So this K value will be always greater than 1 in these cases. So we need not to remember all these things, rather it will be provided, so nothing to worry about that. And if it is like, one second, so what it will be provided in the question. In this example, there is a cylindrical riser, and it is given that the H is equal to D for the riser. Okay, there is a casting. Its dimensions are given 25, 25, 25. 5. So we need to find, first of all, we will calculate the shape. So shape factor is equal to, it's a for casting, so casting is having a shape of slab. It's written a slab. Okay, so this is a slab like this one. So thickness is 5, so we will write 25 plus 25 divided by 5, that is 10. Okay, so here it is given from the graph. If you see, look at the graph itself here. So where is the 10? We get the value around 0.4. Okay, in the range of 0.3 to 0.5, I think. So put it there, it is given 0.47. Okay, so you need not to worry this one, rather you can, it will be provided. So we are getting volume of casting, volume of riser first, isn't it? So volume of riser divided by volume of casting is, we are getting 0.47. So volume of riser is equal to 0.47 into volume of casting, that is 25, 25 and 5. How much is that? 25, 25, 5.47. That comes 1468.75 centimeter cube. Okay, so we got volume of riser, and this is actually D is equal to H, so pi D square by 4 into, that is D, and this is 1468.75. so from here D is 12.32, so we are getting 12.32 centimeter. Okay, so from we got this value. Acha, can we use, let us check with modulus method, because Caine's method obviously we have seen already, it is very lengthy question is coming, isn't it? So let's talk about the modulus method and see if both values are comparable or not. So a modulus method, what is that? MR is equal to 1.2 in of MC. What is MC? Modulus of casting is volume of casting, 25 25 5 divided by 2 into total 6 are there, no, isn't it? So 2 into 25 25 5 into 5 plus 25 into 25. This is just calculate the surface area, and we'll use the calculator. Divided by 2. One point seven eight 1.7857. So MR is equal to how much? 1.2 into 1.7857. How much is that? You got 2.1. Okay. Now this MR is D by 6 is equal to 2.1428. So D is equal to 12.85. Okay. So from here we can see it's almost comparable values are coming with both the methods. So modulus method is more safe, isn't it? Are you get? No, sorry. See here, in this case the diameter is larger, that means it will solidify little late, and in this case it is lesser, that means that the modulus method is much more safe side, isn't it? If you want to be safe, go for modulus method. Oh, okay, so in this question which was asked in GATE 2015, see the safe factors are given in the form of table, isn't it? So here riser volume divided by casting volume is given along with the safe factor. So here what will be the safe factor? 25 plus 15 divided by 5. How much is that? 8. So for 8 it is 0.5. So riser volume divided by casting volume is 0.5. So riser volume will be 0.5 into this volume. Okay, so we will calculate, and from there it is very easy now, isn't it? See, we'll solve that. Pi dq divided by 4 is the volume of riser divided by volume of casting, that is 25 15 into 5, and how much is that ratio? 0.5, isn't it? So from here pi dq divided by 4 is equal to 0.5 into 25 into 15 into 5. So d is equal to how much? That 0.5 into 25 into 15 into 5 into 4 divided by pi is equal to this much. Cube root of this is equal to 10.61 centimeter. This is the value. Okay, next. So this is talking about the location of riser. So we have already discussed about that, where the riser is located. So I told that when the shape is uniform, like this kind of shape is there, casting is there, so where you will put the riser? In the middle center. But if the shape is something like this, okay, something like this, so obviously the riser will be in the heavier side where the material is more, because solidification will start here, okay, from this direction, and solidification will proceed in this direction. So if this is first solidified, so whatever will happen. So here the molten metal will provide the any metal which is required. Okay, but here if the shrinkage happen, which will happen at the end, because this portion will solidify at the end, so in that case this riser will provide the metal required. Okay. Okay, so next we will move. So we have already completed this one. Last was method. One method was there which I have told, that is volume shrinkage method. Fourth method, that is volume shrinkage method. So it is nothing but this is the concept actually. Volume shrinkage is what we know, modulus of 1 second. We know, sorry, we know about let's suppose there is a casting, okay, with having dimensions something length, width and height or thickness. Okay, so we know the shrinkage value. If the shrinkage like liquid shrinkage, we talk about the liquid shrinkage, we know liquid shrinkage, isn't it? So we know that liquid shrinkage, let's suppose it is 6% by volume. So how much we liquid shrinkage, so this much metal is required to be put through the riser. Metal, volume of metal required, volume of metal required to compensate the liquid shrinkage, or you can say volumetric shrinkage. So liquid shrinkage, so that will be equal to, let's suppose this is A%, so that is this much of A by 100. Okay, so this is the volume which is required. Okay, now this is shrinkage volume, which is known as volume of shrinkage. So volume of riser will be greater than volume of shrinkage, then only it can provide the metal, isn't it? So this should be greater than volume of shrinkage. Now it has been found that if volume of riser is 3 times of volume of shrinkage, then it is almost safe. So this is known as volume shrinkage method. Okay, it should be around 3 times more than the volume of shrinkage, and this volume of shrinkage will be calculated from liquid shrinkage value. So in the question, if the method is not provided, if they are telling, they are not writing any method that this is volume shrinkage, by which method you have to calculate. So you have to you have to identify, if liquid shrinkage is given, that means you are going to use this one. If liquid shrinkage is not given, and if A, B and C 3 constants are given, that means you are going to use Caine's method, isn't it? In the Caine's method only we have seen this, sorry, A by minus B plus C. This is the Caine's method, ABC is there. So here you will be using Caine's method. But in case if nothing is given, are you getting, like a safe factor, if safe factor table, any information about safe factor is not given, if it is given, then you are going to use naval research laboratory method. If safe factor is not given, then at the end you are going to use modulus method. Clear? So just to note that, see, the cases are there. First case I am telling, if liquid is given, that is given actually in the question, then which method you will use? So method you are going to use is volumetric shrinkage method. Clear? If values of 3 constants are given, then you are going to use Caine's method. If shape factor is given, then you are going to use naval research laboratory method. And if there is nothing, no information is given about this theory, so any other, like, then you are going to use which one? Modulus method. So Modulus method is, although it's easiest one, and at the same time it is most safe also, because the maximum value is coming, isn't it? When you see the dimensions are maximum, it is coming, so it is not going to solidify before casting in any case. So we will stop here if any question is there. Okay, so this is completed. So in next class we will be talking about these are all discussed already, so we are not going to talk about this. We will go to directly casting cleaning. Pouring time we have already talked. Okay, pouring time is completed. So we will in next class we will start casting defects. Okay, thank you very much.